Right. Good afternoon, everyone. My name is Manos. I'm a solutions architect at AWS. I'm specializing in big data and analytics. So today we're gonna be speaking about big data. We're gonna go through architectural pattern principles and some design patterns. And we have to cover quite a lot. So the way we're going to play it today, I'm going to talk to you some of the big data challenges that I see and I discuss with my customers. And then I'm going to discuss through some architectural principles, some things that you need to remember when you do your architecture. And then we will simplify the big data processing into smaller steps. And then we're going to dive deeper into each step. And then we'll start identifying some tools that you could use on those steps. Then we'll combine all those steps together into some sort of reference architectures. And in the end, we'll finish with some customer examples. Now, the types of big data analytics we're going to discuss today is going to be batch and interactive type of analytics, streaming analytics, and some predictive analytics, some sort of that are powered by some sort of machine learning algorithm. Now, because we're going to speak about big data and the cloud, I'd like to step back a little bit and think how the cloud has evolved. Since AWS pioneered the cloud, it started with virtualized instances where customers were able to spin up virtual machines, and then you were installing your applications, and then you would start running your code. But then that evolved into managed services, where AWS took more responsibilities. AWS then started to manage more on the software stack. So you didn't have any more to upgrade, let's say, application. It was managed by AWS. But still, you had to provision, as a customer, you had to provision to think about servers. You had to think about memory, CPU. You had to think about all this stuff. And this is where serverless paradigm comes. This is where the serverless and clusterless computing comes, which is the evolution, where customers don't have to think anymore about capacity. Instead, you really focus on developing your application code. And when it comes to analytics, that means you're focusing to develop those analytical queries that will make a difference to your applications rather than focusing on upgrading frameworks and upgrading applications. So today we're going to cover, we're going to dive into some tools. And there will be quite a lot of tools, a lot of which are coming from the open source kind of stack of tools, and especially around the Hadoop kind of ecosystem. But also I'm going to describe a lot about some AWS services around the analytics. So let's start with the challenges first. So really, what the customers want to understand is when we have a problem, right? They want to understand what is a reference architecture that I can use to solve my problem, and what tools that architecture has. What tools should I use? And then different tools, how to bring those tools together, and then why to choose one tool over the other. So today's session is about this, really, about understanding the different options and help you choose the right tools. OK, before we start all the tools conversations, let's define some architectural principles. So we have kind of a common framework as we're going to go through those options. The first one is a general kind of good practice and good architectural principles in general, not just when you design big data systems. When you design pretty much any system, is to build decoupled systems. Really separate the concerns. Instead of having a big monolithic application, separate the concerns into smaller systems. And then what that allows you to do, it allows you to iterate on each and every subsystem. And this is how you can truly build and evolve over time. Now, from a big data point of view, really what that means, it kind of breaks down into storage, processing, and analysis of the data. And the way you store the data really shouldn't really mandate the way you process the data, and equally the way you process the data shouldn't really mandate the way you analyze the data. So they should be independent. Now, the second architectural principle is really use the right tool for the job. And in order to identify what is the right tool, there are a couple of questions that you kind of need to ask yourself, and it really comes down to the data structure and to latency requirements that you might have. The third one might not be an architectural principle, but certainly something that definitely we recommend our customers do. And this is about using managed services and serverless services where possible. By doing that, you inherit a lot of engineering effort that AWS has put in place to build those services. You inherit a lot of best practices AWS put in place to make those services scalable, to make them highly available, reliable, secure. And you save also some admin cost because you don't have to, again, to upgrade applications. You don't have to manage service behind the scenes. The other one is to prefer, when it comes to analytical systems and to big data systems, to prefer immutable data sets, like a data lake, and where you want to capture the state of an application to load them as materialized views, rather than updating records that introduce complexity. And finally, cost is part of any architecture, so we will talk today about some ways to optimize cost when you architect systems, analytic systems on AWS. OK. Now let's move on to the simplification of big data processing. So what we're going to do now, we're going to go on each and every step. The steps are collection, storage, process, and consumption. You see those arrows, those doesn't have to be a waterfall process, right? So storage could, you could store the data, then analyze the data, then you can, the process data set, you can then store it back, and then analyze. So it's kind of iterative as well. So what we're going to do now in the next few slides, we're going to go on each and every step, and then we're going to start discussing the technology options when it comes to architecture. So we'll start with collection. So when it comes to collection, and the first thing you have to think about is about the type of the data that you are collecting. So what are the types of the data that I'm collecting? So first, we have data structures, database records. These are data that typically are coming from mobile applications, from web applications, and let's call those transactions. Second category is objects or files. And the third is about data streams. Let's call those events. OK, now I'm going to dive deeper on each and every category. OK, so in terms of the storage, the transactions, really, typically we would store them into a database system, either SQL, NoSQL, in memory cache. It's a database system. The media, the files, they really would go to an object store, and then we'll discuss the options there as well. And then the data stream really will go to a stream storage. So again, now let's dive deeper a bit, and we'll go now in each and every category. Let's start with the stream storage. So when it comes to stream storage, what are the options I have on AWS? So the first, I'd like to kind of introduce Kinesis, Amazon Kinesis. Amazon Kinesis is a family of services. And there are two services that I'm going to discuss today. It's the Kinesis Data Streams and Kinesis Data Firehose. And I will explain what is the use case of using those. So Amazon Kinesis Data Streams is a distributed and durable stream storage that you can ingest thousands or millions of events per second. And what it allows you to do, it allows you to have multiple kind of producers to pushing data to the stream, and then multiple consumers reading from the stream. Now, Amazon Kinesis is fully serverless. It kind of fits into that category we discussed earlier. And what that means, when you provision streams, and you don't have to, to think about CPU, memory, and this sort of stuff. Instead, you provision shards. That's what they are called. And one shard kind of corresponds to 1,000 writes per second. So let's say if your application has 10,000 messages per second that you need to write, then you need to provision 10 shards for your stream. Then what Kinesis allows you will store the data up to a week. And then you can have your consumer's application readings from the stream, and that will allow you to do real-time analytics. Now, we have a lot of customers, though, who don't necessarily want to do real-time analytics. What they want to do instead, they want to capture the data from the stream, and they want to deliver it to a data lake for further analytics later on. And this is where you should consider Kinesis Data Firehose, which is a delivery stream. Think it as a pipe that will deliver your data to a target, and then that target then will be your system that you will do your analytics later on. Now, when it comes to streaming, conversation always will have the word Apache Kafka, and Apache Kafka is also a high, distributed streaming platform. It is durable, and it's coming from the open source community. So there is huge support for Apache Kafka out there. So when it comes to Apache Kafka, as of now, you can kind of fits to the virtualized kind of service where you could install Apache Kafka on EC2s, which that means you have all the configurability by configuring Kafka applications. However, that means that you have to kind of have admins and around the Kafka. You need to administer the Kafka clusters. And this is where we released in reInvent Amazon MSK, which MSK stands for Managed Service for Kafka. So we heard our customers asking us to help them to manage more on the Kafka layer. And we have now a service. At the moment, it's in preview, but it's in public preview, meaning that actually you can go, if you're an AWS customer, and try it out. In fact, 3 days ago, it was released in Ireland as well, in Europe. Now, Amazon MSK will fully manage Zookeeper for you, and then with the console or the APIs, you can create Kafka clusters in minutes. Moving on, we will have quite a lot of those tables. Some of them I will skip, but the presentation slides will be made available. The key point here, when you select and you look over all the options, really think of the use case first. If the use case is just one single message to one consumer, one producer, and when you have the consumer reading from the message, you want a visibility timeout, this sort of behavior, then SQS is the right service to go for. Those queuing systems are still valid. But when you've got like multiple consumers, multiple producers, and then is when you have the Kinesis or Kafka. And how to choose between Kinesis or Kafka, what Kinesis will give you a tight AWS integration. It's a fully managed service. You don't have to think about servers. What Kafka will give you, the open source kind of tooling around it, full configurability with the kind of overhead of the admin overhead, which is reduced, let's say, when you go to MSK. OK, moving to the next category, the file category. And the service, really the de facto service to store files into AWS is really Amazon S3. And Amazon S3, it will allow you to store any amount of data, and you can retrieve any amount of data. There are a lot of use cases for Amazon S3. In fact, it's one of the oldest services. It's really integrated with the rest of AWS services. But one of the use cases, very strong use case, is to use Amazon S3 as the sender of your data lake. And there are a couple of reasons why S3 is actually good for being the storage for your data lake. It's open and comprehensive, and that means that apart from integrating with the rest of the AWS services, actually outside of AWS, like Hadoop clusters, like our partners, Cloudera, Hortonworks, they speak natively to S3. Now, what S3 will allow you by using it as a storage, it will really allow you to decouple storage and compute. And this is quite powerful when it comes to big data analytics. And I would like to explain a little bit more about that. So by having a storage outside of your, let's say, Hadoop cluster, what that allows you to do, it allows you to run what we call transient clusters over your data set. And what is the benefit there? By having transient clusters, you could define clusters that are short-lived, and you can introduce some sort of steps when you configure them. And when the steps complete, then the cluster can terminate, which means that you've done your analytical job, you've stored the output again back to S3, and the cluster has completed. Now, what's the benefit there? The first apparent benefit is the cost. With AWS, you pay only for what you use, meaning that if you have a cluster for 10 minutes, you pay for 10 minutes, and goes on. Now, the other benefit, though, which is around really the innovation that allows and the flexibility that gives you. Because now you can actually run multiple clusters, multiple Hadoop clusters, and they might have different configurations. So for instance, you might have like Spark, Apache Spark, that really, when you're doing interactive analytics, Apache Spark really wants that memory. So you can have those R5 instances that are memory optimized. So that you can have a Hadoop cluster like that. But also you can have GPU Hadoop clusters to run TensorFlow for machine learning. So with the same data set, 2 different clusters, and really that allows you to really build the right Hadoop cluster for the job you need to complete. Regarding the cost, I mentioned also, this kind of the cost saving is enhanced by Amazon EC2 Spot. So there is a really great use case of Spot instances with Hadoop, Amazon EMR. And why is that? If we think about Hadoop in general, Hadoop has been architected to tolerate individual or even multiple node loss, even when jobs are running. And this is a great, if you think about the Spot instances means that you are bidding for unused capacity in AWS data centers. And if you combine those 2 together, it means that you can do a combination and create like on-demand instances, which is like the standard where they don't get interrupted, is the on-demand instances, with combinations with Spot instances. And then you can have your transit cluster, and Spot instances will give you up to 90% saving when it comes to cost. This does matter when you have clusters of 10, 20, hundreds of nodes. Makes a big difference. Other reasons for S3 being ideal for the data lake, to be the storage of the data lake, is its durability. And it has been designed for 11 nines of durability. And one of the reasons that it achieves that durability, S3, behind the scenes, is using our availability zones. So within a region, when you put data into S3 will replicate the data automatically for you. There is no additional charge for that. It's the default behavior. So that is how S3 is durable. One of the ways that, one of the reasons S3 is durable. It's secure. So S3 will allow you to encrypt data in transit, will allow you to encrypt data at rest. And it's cost effective. And I would like to actually expand a little bit more of ways to cost optimize Amazon S3. And one of the ways to optimize Amazon S3 is to use those tiers, those data tiers. So for the kind of the default standard tier is for the frequently accessed data. So for the data that you're doing analytics frequently, that will go to the Amazon standard S3 tier. But then what S3 actually gives you the option to move data to infrequent access. And then this is where you save cost by moving the data down to infrequent access. And there are, let's say, cold storage, which is like archives. This is the Amazon Glacier, which is kind of very cold storage. This doesn't necessarily make the data available for you to do analytics at the same time. But with Amazon S3 standard infrequent access, actually you don't compromise performance. So you can actually have the data available to do analytics. It's just the pricing model that works differently. With Amazon Glacier, though, you save on cost significantly. But the data is stored as archive. Last week, we made also available the deep archive, which is the cheapest way to store data, basically, on AWS. But the trade-off there is the retrieval times is hours rather than minutes. OK, about HDFS. So a lot of some discussions with customers about HDFS. Like, if you're familiar with Hadoop, HDFS is the Hadoop distributed file system. Is where Hadoop, by default, will store the data. And customers ask, like, OK, I have the data in S3. Do I need HDFS anymore? And the answer is maybe. And there are some use cases that you could actually use HDFS. So what are the use cases? If you are doing analytics over the same data set, actually you could benefit by loading the data into a HDFS. Our managed Hadoop EMR, it comes with HDFS. So you could leverage HDFS. And if you engineer Hadoop, you could potentially get use of the kind of data locality, although it's hard, because HDFS is also distributed, so there will be data flowing around the nodes. But there is that room for HDFS that can be used if you do analytics over the kind of the same. Rather than fetching it from S3 all the time, do analytics over S3 over HDFS. And there is actually a little utility that comes with EMR called S3 dist CP, dist copy, that will use a map-reduced job to fetch the data distributed in parallel from S3. Okay, I'd like also to mention about metadata. In order to fully decouple your data from compute, data is one part of the equation. Also, metadata is the other part. So you need to have both outside of the cluster to be able to do those transient AMR clusters. And what are the services about the metadata? I'd like to highlight first the AWS Glue catalog. So AWS Glue catalog is a fully managed data catalog, and it's Hive Metastore compliant. Now, what is the purpose of Glue catalog? Really, it's there to be the unified central data catalog across your data sources that you want to do analytics on. And then you have the Athena, EMR, and Redshift, all the kind of group of AWS services that are integrated with the Glue catalog, so you can explore those data sources right away. There will be no effort to plug them together. Glue has also a kind of a utility, let's say, the Glue crawlers, which is an application that you can point to your data sources. That could be in S3, that could be also databases, and then it will explore the data and will try to identify the metadata for you so that it will create those tables to make it a little bit easier to find those schemas. It kind of makes it easier. When it comes to data lakes, and okay, I'll say that. So when it comes to data lakes, you still have to go to a few places, let's say, to create it. So we've discussed about S3 for the storage. We've discussed about the metadata, the Glue catalog. There are also, what we call the IAM, identity and access management, to do security. So there are a couple of places that you need to go in order to create a data lake. So we identified that, and then we've released Lake Formation, and that is currently in preview. So Lake Formation is there to help you, assist you, to create a data lake in AWS within a few minutes. So it does build over those services I described. So it will use S3 behind the scenes. It will use Glue catalog. It enhances those services with additional metadata. And also, it will introduce some data quality jobs that you will do on the data to kind of deduplicate the data or find matches where there is no common ID available. So I'd like to highlight that this is a private preview at the moment, so you need to sign up. And then it's kind of a whitelisting, so it will be some kind of conversation about your use case before you get your hands, let's say, to Lake Formation. And for completeness, just to highlight the Hive Metastore, Glue catalog is one of the options. It's the easiest option. But for completeness, also, I'd like to point out that you have also Hive Metastore that you could build, for instance, and you can host it on Amazon RDS. Okay, moving to databases, there was a session on database, so I'll go through a bit quick from databases. Databases, from an analytics point of view, could be either our source of the data, that we pull the data from the databases so that we can do later analytics, can be also the target of the analytics. You might have built some analysis, some data, and then you want to push that data back to a database so that you have like a real-time dashboard or something. Really, the key message here is the best practice really is, you use the right. There are so many database options on AWS. You need to use the right tool for the job. And just to help you identify the right tool, that comes back to those questions that you need to ask yourself. And the main two questions is about the data structure and how the data will be accessed. So if your data structure is still is kind of a fixed schema, then yes, probably SQL is the way to go, especially if you have complex relationships and if you have table joins. If this is the way you access the data, then you should evaluate SQL databases first. If your data, though, has no fixed schema or it has a simple key-value pair, then you should evaluate first a NoSQL database And if your latency requirements are really low to the microsecond, then yes, you need to think of an in-memory cache in front of your database system or in front of the NoSQL database. And if you have graph kind of traversals for querying, or if you have graph structures in your data, you need to evaluate first a graph database. So there are quite a lot of characteristics. Again, those slides will be made available. The main two characteristics, it's line 1, which is the use case, line 3, the shape. So these two are the ones that really will show you what sort of database systems to use. Okay, moving to the next step, process and analysis. So when it comes to process and analysis, I'd like to highlight now the services, what they do, and then some use cases. First, we'll start with interactive and batch analytics. So some service, a couple of options there. So we've got Amazon Elasticsearch. Amazon Elasticsearch will allow you to spin up Elasticsearch clusters in minutes. And what are the use cases for Elasticsearch? Well, the strongest use case I am seeing is about logs analysis. So if you have logs and you want to have dashboards with Kibana, this ELK stack, Amazon Elasticsearch is great. The other use case I see as well for data lakes is also some metadata indexing. So if because Elasticsearch is a search system, and it will allow you to actually query using some sort of search. So it could actually do a lot of stuff, like even tolerate typos. It could do this sort of experience, search experience to your queries. You could index metadata to Elasticsearch about your data, and then you can have an additional searchability over your data sources in a data lake. This is also another use case. So it doesn't necessarily have to be something that you are querying for analytics. It could also play a role to help you explore your data. Amazon Redshift and Redshift Spectrum. The Redshift is our fully managed data warehouse. And Amazon Redshift is what we call an OLAP system, an online analytical processing system, or a massive parallel processing system. Redshift will allow you to query petabytes of data. And Amazon Redshift really, it's kind of it will be like a schema on read kind of a system, which means you define the schema up front, kind of highly structured data, what you put in Amazon Redshift. Now, there is also an extension, Amazon Redshift Spectrum. And Amazon Redshift Spectrum will allow you to query data in S3. So I would like to explain a little bit more what is the use case of Spectrum. So let's imagine that you have a data warehouse, and this is where you drive your monthly or weekly or daily reports from. So the data there is high-quality data and highly structured data. But there is still a lot of data that reside in your data lake in Amazon S3, and for one reason or the other, they didn't make it all the way to the data warehouse. Maybe it was lower quality, but they still hold value. So what Redshift Spectrum will allow you to do, it will allow you to combine data from that side of the data lake with your high-quality data from the data warehouse, Amazon Redshift. So this one single interface. And actually, Spectrum will be able to query to limits beyond Redshift, because Redshift has to petabyte. Actually, to Spectrum will go to exabyte, because it will utilize the nodes closer to S3, not necessarily your Redshift cluster. We'll just bring the results back to your cluster just to present it back. Amazon Athena, another great service for kind of the serverless category that will allow you to do SQL queries over your data in S3. The skill set that you will require to be able to query with Athena is really if you have Presto skill, or Presto, the interface will be an ANSI SQL kind of interface. So you will do select statements and this sort of stuff. And then, of course, Amazon EMR. Amazon EMR really, it's a great service. It's the managed Hadoop, our managed Hadoop service, and it will give you all the frameworks up to date, including Presto, Spark, Hive, HBase, and what is great about EMR, and it's a kind of an exception, let's say, because actually Amazon EMR, it's like most of managed services, you don't have access, like root access. We don't offer that in most managed services. That's not the case for EMR. You can actually get root access on EMR, and then you can bootstrap it, and you can install your own applications. And it's a great way to get to use there is a huge ecosystem on the Hadoop technologies in general outside of AWS. You could integrate those with Amazon EMR. Okay, going to stream analytics. So regards to stream analytics, there are a couple of options. Again, Spark streaming with EMR. And there is also, back to the Kinesis family, the Kinesis data analytics, that you can configure data analytics, Kinesis data analytics to read from Kinesis data streams. And then again, with some sort of SQL interface to aggregate or do analytics on the streams. And you can always create your own applications using the Kinesis client library or with Lambdas. I think there was some similar use case in the previous session about how to do, to read from Lambda for notifications. And moving to predictive analytics, I won't explain every single service. I think there was another session earlier, which is a great session from Neil, about predictive analytics. The key message here I would like to point out, you've got the option of, we have those 3 layers from frameworks, platforms, and applications. When it comes to frameworks, it's for machine learning practitioners. You get the images with those frameworks pre-installed, but you have to do the machine learning. You have to do, all the complexity of the hyperparameter tuning, traditional machine learning kind of tasks. The platforms is kind of helping those machine learning experts to do tasks like giving them a Jupyter notebook, a familiar interface, and then you can use the API, SageMaker API, to create, for instance, models, and then you can deploy the model. So it's one kind of place that you can do all your machine learning tasks for the platforms. And for applications, then it's just for developers who want to use machine learning in their application, but they don't want to implement machine learning. So we have some algorithms that they're successful at Amazon.com, like Comprehend, that does the natural language processing, and you can integrate that with calling those APIs. Just a couple of examples before we move on. So when it comes to batch analytics, think of it as reports that are running monthly, weekly, or daily. And the first service that comes into mind is Amazon EMR with tools like Hive or Spark. Interactive analytics, think of it like as a self-service dashboard, something that maybe you want to get some answers from the system within seconds. So the services there will be Redshift, Athena, or EMR running Spark, or EMR running Presto. When it comes to stream analytics, again, EMR, you can utilize Spark streaming or those Kinesis data analytics services. And when it comes to predictive analytics will be either batch or streaming, depends which service you use. And there are so many services there from AWS. But the key message I would like to say is like the Amazon SageMaker really is worth noting that, because it's the single place that will for machine learning practitioners to do all the machine learning in one place. So I'll skip through those slides quickly because we're going to discuss about the next topic, which is the ETL. So ETL, quite a lot of discussion around it. Sometimes we think like when you do ETL, which stands from extract, transform, load, you might lose value as you change the data. But what is a good case for ETL is really to prepare the data in a format that is really more suitable to do analytics, like partition the data, convert them from a text format into a Parquet format or an ORC format. And there are a couple of options when it comes to ETL. I'd like to highlight Glue ETL. Glue ETL will allow you to run Spark or Python shell. And it's kind of the serverless type of category where it kind of abstracts the server complexity from you. You just do define data processing units, and then you can schedule those jobs to run. If you want to capture changed data capture from a database, then database migration service is also an option. Glue is not able to do that. Or you can look on the partner solutions, especially when it comes to change data sets from change data capture from relational databases. OK, moving to consumption. So when it comes to consumption of the data, which is kind of our last step, when it comes to consumption, I see two main categories. One category is really those business users that they want to make sense of the data. And what the service there is really, applications like visualization applications like Tableau. Or we have also Amazon QuickSight, which are our fully managed business intelligence tool. And also Kibana. Kibana will allow you to run visualizations in front of Amazon Elasticsearch. The other category is those data scientists that they want to get an access to an endpoint, and they want to just do statistical analysis using RStudio, for instance. For those who, Athena, for instance, or Redshift will have a JDBC driver that you can connect your data, and you can start pulling data from there, or you can just directly query them. Okay, the next now I'm going to put all of them together, and then we'll start actually discussing some design patterns for the data. So we kind of saw that slide before. Also notice this ETL arrow there that storage and processing, can go. You can analyze and then back store and then analyze again. Okay, let's see some design patterns. Okay, that kind of goes back to the temperature kind of data. So on the left-hand side, you see the hot data, meaning data that are short-lived or data that kind of lose value as they age, and data that you typically want to retrieve faster. And on the other end is the cold data. And the ultra-cold, let's say, is those archives. So as the data arrive, you see Kinesis as storage for the kind of the hot data, and then for analysis, Spark streaming, Lambda, KCL, applications. For interactive analytics, Redshift to query data to load data from RDS or Amazon S3 and then allow you to query data. And also Amazon Athena or EMR with Spark on Presto running over S3. And for the batch analytics, Hive is a kind of a typical tool running over EMR. So the lower those tools are, the bigger is the response time back to you. Okay, when it comes to streaming analytics, a stream typically arrives to Kinesis, Amazon Kinesis data streams. And then you might have the data analytics, Kinesis data analytics to do real-time analytics. Other options you have there, it could be Lambda to read from the stream, could be a KCL, your library, or you could actually do like micro-batching as Spark streaming does with Amazon EMR. You could utilize those ML applications. So for instance, if you want to start do some ML as you process the stream, you can utilize those endpoints that are already there for you. And you can, let's say you identified something and you want to do like a fraud alert, then you can use like SNS to push a notification out to users. And then you store the data to S3, which is your data lake for further analytics later on. And if you want to capture the data just to have a real-time dashboard or something that will feed the dashboard, then it's a good practice to actually export like an app state and have another system that could be a database, like DynamoDB, for instance, and then have sort of KPI tables or sort of visualizations in front of the streaming data. I'd like also to, in that case now, I'd like to introduce like a customer use case, which is Hearst, which is a media and information company. Among other things, they are managing websites for those magazines. And they're using Kinesis data stream. And I would like to highlight here the use case that you can have multiple consumers from the same stream. So with Kinesis data streams, one route is we're using Lambdas to pull the data from the stream and then doing the analytics and then push the results of the analysis into DynamoDB, and then that exposed then those tables, they're exposed from an API, and that could drive dashboards. But on the other route is with Kinesis data firehose to capture the streaming events and deliver them to S3 for further analytics later on. Moving to interactive now and batch analytic kind of design patterns. Again, we start with stream. The fact that you might do interactive and batch analytics doesn't mean to say that you don't have streaming data. So you could have stream data, And again, in order to capture them and put them to S3, Kinesis Data Firehose is a great service. But you also might have files that you can deliver directly to S3. From Kinesis Data Firehose, it's a delivery stream. Think it as the pipe that delivers. So the supported targets is, apart from S3, is also Redshift for data warehousing or Elasticsearch to do those kind of Kibana dashboards or doing analysis. To do interactive analytics over S3, a great tool is Athena as well, but also running EMR clusters with Presto or Spark for interactive analytics. For batch analytics now, EMR again is a great tool, or the glue jobs is also possible. And with EMR, you can have the main two frameworks that I'm seeing now is Spark and Hive, not Pig, for instance, but primarily Spark and Hive. Yeah, so the top layer is the interactive analytics. The bottom layer is the batch analytics. OK, another customer example that I would like also to highlight is FINRA. So FINRA is the financial regulatory authority over in the USA. And they're using AWS for a lot of their analytics. And they're actually ingesting every day, even billions of records daily. And data are coming from various sources into S3. And from S3, they have multiple systems doing analytics. And this is back to where we say you can have multiple clusters doing analytics, and those clusters will be specific to the workload that you want to support. So they have, like, for instance, Redshift for kind of predefined queries, and they have then different EMR clusters. They have multiple EMR clusters, not just two, actually, as is this diagram. They have multiple EMR clusters to do interactive analytics or surveillance analytics to detect fraud, etc. Now, FINRA has strict kind of security requirements, and they were utilizing things like a VPC, that's a virtual private cloud, and EMR can be hosted into a VPC, or Redshift can be hosted into a VPC. They also use encryption at rest and in transit from S3. And of course, they're using CloudTrail. AWS CloudTrail is for audit. It will capture every single API call that you do to AWS, and then you can have an audit trail for any action that happened on your infrastructure. And then I'd like also to say, like, the kind of the final pattern is a data lake architecture, a reference architecture. So you can see here the Amazon S3 is really the center of the data lake, plays a central role. I'd like to say also with Glue Catalog together, because you need to have those metadata as well to be able to query. So there are, again, multiple ways to put data into S3. If you have relational databases and you want to have those data change data captures, then with database migration service is a great way. The other way is with Glue ETL jobs to put the data into S3. Streaming data arriving, Data Firehose is a great way. You could use Kinesis Data Analytics to do maybe analytics and then put them back to a stream and then put them back to S3. From Amazon S3, you can then use Lambdas or Spark Streaming or, again, those KCL applications to do a real-time kind of analytics, and then you can load the data to some sort of application state or a materialized view so that you drive those dashboards, or you can have then the batch and interactive layer above your data lake so that you can explore data in the data lake. Services there we discussed here, Redshift, Athena, Presto, Spark, Hive, all these sort of tools for batch and interactive analytics. Okay. To summarize, I would like to play back those architectural principles that we discussed in the start of the presentation. We're starting from building decoupled systems. And really, today, we discussed how those steps from collection to storage to processing and to analysis, and what then tools you have to use. So use the right tool for the right job. And then on each and every step, remember those kind of options you have and those kind of decisions that you have to make. We discussed also today about managed services and serverless services and what are the options that AWS gives you. Where possible, do leverage. You inherit a lot of best practice, and you do save a lot of reduce the cost, especially admin cost. Do prefer immutable data sets, immutable logs, data lake kind of architecture that you append to the data sets rather than updating and overwriting. And of course, be cost conscious. Big data systems don't necessarily have to be expensive and have big cost. With that, I'd like to thank you for your attention.